Chapter 9, Lesson 6 is the quadratic formula. So the quadratic formula is opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, when we put this in, there's more than one thing on the top and more than one thing on the bottom, so we need to add extra sets of parentheses. And we've already looked at this negative b over 2a part of the formula as the axis of symmetry. And then this part of the formula, the b squared minus 4ac, is called the discriminant. And we're going to talk more about that in a minute. So we're going to use the quadratic formula when we are trying to solve quadratics that cannot be factored. Now, on these first couple, the quadratics can be factored. However, we're going to do the quadratic formula to show that either way you do it, you'll get the correct answer. So in this one, a is 1, b is 2, and c is negative 3. So according to the formula, I do the opposite of b, which is negative 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times 1 times negative 3, all over 2 times 1. And something important to note is that the b term, because you're squaring it, is always going to be a positive. So when I type that in, I'll do open parenthesis, negative 2 plus the square root of 2 squared minus 4 times 1 times negative 3, close, divided by 2 times 1. And so my first answer is 1. And then the second time I'll do opposite of 2 minus the square root. And the second answer is negative 3. Now we can factor this to prove that we did it right. Factors of 3 that subtract to be 2 are 3 and 1. Sign chart says the bigger one gets a negative. But then when I set them up, I get x equals 1 and x equals negative 3 when I solve like I did yesterday. So in number 5, originally we would solve this as a window method. We'd do 2x squared and negative 5, which is 10. And factors of 10 that subtract to be 9 are 10 and 1. And then following the sign chart, I get the binomials of x plus 5. So I know that one of my answers is going to be negative 5. And my other answer is going to be 1/2. So now, doing it the quadratic formula way, I'm going to do the opposite of b, which is negative 9, plus or minus the square root of 9 squared minus 4 times a times c, all over 2a. So I'm going to start with negative 9 plus the square root, 9 squared, 4 times 1 times negative 5, 4 times 2 times negative 5, divided by 2 times 2, gives me 1/2, and negative 9 minus the square root of all of that gives me negative 5. Now, we still are going to have cases where we only have one solution or no solutions. And so what we can do is use the b squared minus 4ac part of the equation, which is called the discriminant. And that will tell you how many solutions there are going to be. So if you tried typing this into your calculator and you got an error, that tells you that it's probably a no solution. So the quick way to check that would be to check the b squared minus 4ac part first to determine how many solutions you're supposed to be looking for. So in this case, if I just do the b squared minus 4 times a times c part here, I get 0. So that tells me this is going to have one solution. So I set up opposite of b plus or minus the square root, b squared minus 4ac, all over 2 times a, adding the appropriate parentheses around, and each time I type it in, I get -4. So there's only one solution, which means we have a parabola sitting right here on the axes at -4. This one, just a quick check. There's no factors of 12 that add up to 3. So I think this one is already going to be a no solution. But I'm going to check opposite of b. We just need b squared minus 4 times 1 times 12 gives me -39. And so I know this one is going to be an error or a no solution. This one, the first thing I'm going to do is add 7. So just a quick check, factors of 14 that add up to 12. I think they're going to be decimals. So I'm going to do opposite of b plus or minus the square root, b squared minus 4ac all over 2a. And I got -0.65 and -5.34. A roofer tosses a piece of roofing tile from a roof onto the ground 30 feet below. He tosses the tile with an initial down velocity of 10 feet per second. Write an equation to find out how long it takes the tile to hit the ground. Use the model for vertical motion. H is the height of the object after t seconds, v is the initial velocity, and h is the initial height. So we're going to have h equals -16t squared minus 10t plus 30. So instead of trying to factor this, we're going to do opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. Square root 10 squared minus 4 times -16 times 30 divided by 2a. So for the first answer, I got -1.71 seconds, which, because it's a word problem, I know that that is not the right answer. And for the second one, I got 1.09 seconds, which that sounds good. If I throw something off a roof, it's probably going to take a little over a second to hit the ground. Lupe tosses a ball up to Quinn, waiting at a third-story window. The initial velocity is 30 feet per second. She releases the ball from a height of 6 feet. There's her equation. If the ball must reach a height of 25 feet for Quinn to catch it, does the ball reach Quinn? And it says put 25 in for h. So put 25 equals -16t squared plus 30t plus 6. And again, we can't solve equations until they're set equal to 0. And when I take 6 minus 25, it's -19. And it says use the discriminant to check for an answer. And I get -316. So that tells me that no, she will not catch the ball. The other thing I could do is look at my Desmos or my graphing calculator. And I have this -16x squared plus 30x plus 6. And my other equation is at 25. So when I zoom out here, I can see that the ball will only get up to the highest point of 20 feet. It will never actually hit the 25-foot mark. So I know that that is not going to happen.